Hi students, in this lecture I am going to discuss problems. Let us see first one. Let's see the question given. A particle of mass m and charge q moves with a constant velocity v along the positive x direction. It enters a region containing a uniform magnetic field directed along negative z direction extending from x equal to a to x equal to b. The minimum value of v required so that the particle can just enter the region x greater than v is. So given for 2 marks in 2002. Let us see. If you remember question number 7, almost same question. We can see once question number 7 to solve this one. Now see how to solve it. So first write down the given data. So given mass is m, charge q. Mass is m, charge q. And strength of the field, it is given b. And coming to magnetic field, direction given negative the direction. So b bar, that is equal to b into modulus value, direction minus k cap. Now condition is minimum value of v required so that the particle can just enter the region x greater than b. So we have to find v minimum so that it is able to enter the region x greater than b. Right? And given velocity along positive x direction. Let us make a diagram. Suppose this is now x-axis and this corresponds to x equal to a and this is x equal to b. Okay. So condition given that magnetic field extends only in this region. Okay. And direction is negative z direction. Right. And velocity given along positive x-axis. Now see carefully. When it enters at this point and velocity along positive x. Positive x. Now right here f bar equal to q into v bar cross b bar. So first we have decided direction of the force. And you should be very careful here. What is the charge given? It is given, see once carefully, mass m charge q. Velocity along positive x direction. Nowhere mentioned about the sign of the charge. Okay. I assume it is now positive. Okay. If it is a positive, direction of velocity, positive x. Positive x means I cap. B bar, negative z axis, minus k cap. I cap cross minus k cap. That is j cap. Okay. Because k cap cross I cap is j cap, right? So I cap cross k cap minus j cap, minus of minus plus j cap. Let us take this is x and this is y. Okay. Now motion is confined to xy plane. That means now motion will be like this. It is a part of a circle. It follows path like this. Now condition is it has to enter this region. Okay. Now recollect that question number 7. In that you can see width of the magnetic field given D, right? Now in the place of D, in the place of D, it is now P minus A. That is the only change. It is in the place of D. We have tried B minus A. This is the width of the magnetic field. And there we have discussed three conditions, or you can say three cases. That is, if D greater than or equal to R radius, in that case, deviation equal to 1/8, right? Greater than or equal to R, deviation 1/8. If D slightly less than R, then deviation will be 90. Deviation is equal to 90. D slightly less than R. Okay. If D less than R, if D less than R, okay. So first case equal to R, R greater than R, deviation 180. D slightly less than R, deviation 90. D less than R. Then see what we have done. Sine theta, where theta stands for deviation. Okay. If theta is deviation, sine theta equal to D by R. So these three cases we have discussed in question number 7. Now, see what we have to focus. If D less than R, then it will come out like this. Okay, this is a case. This is for this third case, D less than R. Okay, because if you are taking the first case, see what happens. I'm showing here. In first case, it follows semicircular path and comes back. Okay, this is a case 1. It is D equal to R greater than R. That is case 1. Second case is slightly less than R. There what happens is it follows now 1/4 of a circle and it goes like this. That's why deviation 90. Okay. That means here what happens is particle moves along this line, along x equal to b. Okay, along this line. That means it is on the boundary. Means not entering into x greater than b or not coming to x less than b. It is simply moving like this. That is the second case. But we want it should enter into x greater than b. That is now third case. Therefore, I am writing here D means b minus a. B minus a should be less than R and R equal to mb by bq. So I hope you are getting it. Otherwise, refer once question number 7. Okay. Now see carefully. From here, what we can write V value, V equal to VQ into V minus A upon M. Okay. Sorry, not equal to. So V should be greater than. Now question is that minimum value of V. So when they ask minimum, V should be, if it is slightly greater than this value, slightly, then it enters into this region. Okay, I am repeating. If V value slightly greater than this value, then it enters into this region. If V equal to this value, remember, it does not enter into this region. Okay. If you strictly speak, if V equal to this value, it won't enter into this region. So V must be slightly greater than this value. Okay. Right. So option is, it is option B. So there we have take V value slightly greater than that value. Then only it enters into this region. Okay. Right. It is option B. Right. Next, see question number 17. Let's see the question given. An electron moving with a speed u along the positive x-axis at y equal to 0 enters a region of uniform magnetic field B equal to minus B naught K cap. That means magnitude B naught, direction is minus K cap, which exists to the right of y-axis. You can see diagram here. The electron exits from the region after some time with the speed v at a coordinate. Then, so given for 2 marks in 2004. And here directly we can verify options because now only magnetic field is present. And we have learned that because of magnetic field, speed does not change. If you are knowing that key point, now you can say option A is not correct. Option C also not correct. Okay. So option B and option D, right? Now again in these two, we have to verify is y coordinate positive or y coordinate negative. So for this, we have to see in which direction force is acting. Okay. Let us see now. So now we have to verify force, direction of force, direction of force acting on that moving charge, that is given by F bar equal to Q into V bar cross B bar. Okay. And remember, charge is given negative electron. So you should not miss it. This is one possible mistake. Okay. Charge given negative. So write here negative sign. Otherwise, we may miss it. Coming to V bar. See, what about V bar? Velocity along positive x-axis. So I'm writing here I cap cross B bar direction minus K cap. Okay. So I'm taking minus inside. So it becomes plus remaining I cap cross K cap. That is minus J cap. Right. I cap cross K cap is minus J cap. That means y will be negative. So y negative means see which option? It is option D, right? See the question what is given here. The electron exits from the region after some time with a speed v. See what it means. Exits from the region. That means it exits after completing half revolution, right? Comes out of the region like this. We got minus j cap, right? Minus j cap means it is now following path like this. After completing half revolution, it comes outside. So while coming outside, it will be negative y coordinate. That means option must be D. So that's why I'm saying while you are focusing force, keep in mind what is the sign of the charge. It is electron. By mistake, if you are missing that sign, you will get option B. That's why there is a possibility of making mistake. That's why keep in mind what is sign of the charge. Right? See next one. A magnetic field B bar equal to B naught J cap exists in the region. It is in between A and 2A. And again, next see, direction of B bar changed. in between 2a and 3a. And given b naught is a positive constant. A positive point charge, given charge is positive, okay, moving with a velocity. Velocity is now along positive x-axis. And given v naught is a positive constant. Enters magnetic field at x equal to a. The trajectory of the charge in this region can be like, so given for 3 marks in 2002, right? So enters at x equal to a, right? Enters here. So enters here. Field is along positive y-axis. Then see direction of force. Direction of force will be given charge is a positive, right? Charge positive means, then see what we get. Q into V bar cross B bar. V bar, V, positive x-axis, I cap cross J cap. It is a K cap. So because of this field, direction of force is along positive z-axis. That means C, which is possible one. Option A possible, option C possible. Because here velocity along positive x, force is along positive z-axis. So force must be like this. So path must be like this, okay? Path must be like this. This is okay. This is also okay up to here. Coming to here, given negative z, therefore B and D, these two are not correct. So AC. Out of AC, now which is the correct one that we have to focus. So what I'm saying is from A to 2A, this region, it is okay. This is also okay. Part of a circle. And what is now after 2A is a path like this or path is like this. Okay. Now see carefully. I will make a diagram for this to get more clarity. So first of all, I'm taking option A. In option A, you can see this is A and this is 2A. From A to 2A, it is now part of a circle like this. Okay. It is circle, a part of a circle like this. You can see now at this instant, direction of velocity. It is always along tangent, right? Tangential to path. So at this instant, velocity will be like this, along tangent. And you can see now field is along negative z-axis, right? Beyond 2A, along negative z-axis. Then see what happens. So I'm taking for our comfort, let us take this as x-axis. It is a complete our choice. I'm taking this as x-axis. And you can take y is now into the boat, and this is now z-axis. So here what I have done is I'm just rotating axis. Okay. Actually, this is x-axis and this is now z-axis. So for our comfort, what I'm doing is I'm rotating now here axis. Now I'm taking this is x-axis. This is now z-axis. Right. Now see direction of magnetic field. Now direction of magnetic field is reversed. That means now velocity along positive x-axis according to our coordinate system. Okay. Here I have taken rotation of axis. Now F bar equal to Q into charge given positive. V bar cross V bar I cap cross B bar minus J cap. Okay. So I cap cross minus j cap. It is minus k cap. Remember here I am rotating this x and y axis. Okay. This is a completely our choice to understand easily. According to this is a positive jet. This is negative jet. This is velocity vector. Now force vector is like this. Okay. This is a force vector. Then what happens is path will be like this. Okay. Because velocity in this way, force is in this way. So velocity, so path will be now, it becomes like this. Okay. That means the possible option is now, it is A. Okay. C is not possible because velocity like this and force like this. Then path will be like this only. That's why C is not possible. So I hope you are getting clarity why option A is correct. Option C is not correct. Okay. Right. Now see next one. A particle of mass m and a charge q moving with velocity v enters region 2 normal to the boundary as shown. Region 2 has uniform magnetic field B perpendicular to the plane of the paper. The length of the region 2 is L. So same question we have solved, right? That is question number, yes, 16. Okay. 16. Again, same question here. 2008 for 4 marks. Given for multi-correct. So enters region 3. Path length in region 2 maximum. Right. Let us see when it enters region 3. Just now we have discussed, right? So if this length is less than r, then it enters into region 3. Okay. Right now. See what we get. Okay. First focus now that given diagram. Cross it is into, and this length is given as L, region 1, region 2, region 3. So just now we have discussed that if this L is less than R, then particle enters into region 3, right? L less than R means mv by bq. Okay, right. Now see options. What they have given. If in terms of V, right? So V should be greater than L VQ upon M. Check once. V should be greater than L VQ upon M. So it is option 1 is correct. Right? It is option A is correct. So B not correct. Next, coming to C. Path length of the particle in region 2 is maximum. Region 2 path length is maximum. See, 1 it will be maximum. Okay. So in this what we can do is, if we are taking L is greater than or equal to R. Okay. L is greater than or equal to R. In that case, particle, it will complete half revolution while coming out. Okay. I think here sign of the charge is not given, right? Charge Q may be positive, maybe negative, and that is not important for us. Okay. Only thing is that if the particle completes a half revolution, and see when this happens when L is greater than or equal to R. In that case, path length is maximum. And that path length, how much? It is equal to pi into r, right? This length is pi r. So condition is that L should be greater than or equal to r, and r value mv by bq, right? Because you can see that question number 7, we have discussed that in this case, deviation will be deviation will be 180, right? Slightly less than r, deviation is 90. Less than r, deviation is, it is given by sine theta equal to d by r, right? Okay, now see the option given. Coming to option C, V equal to QLB. V equal to means if you are taking L equal to R, okay? Condition is greater than or equal to. Therefore, if I am taking equal to, then what happens? L equal to mv by bq. So V equal to bql by m. So option C also correct. Path length is maximum. Okay. In fact, V value. So here what we have to, V should be greater than or equal to bql by m. Equal to is also there. That's why C is correct. Next. So option A correct, option C also correct. Next, coming to option D. Time spent in region 2 is same for any velocity v as long as the particle returns to region 1. See the sentence carefully. Time spent in region 2 is the same for any velocity v as long as the particle returns to region 1. You can see it returns to region 1 only if it follows semicircular path. Okay, and this happens when velocity, or you can say when L is greater than or equal to R. In such a case, time taken will be pi into m by bq. If you remember, time period of revolution t equal to 2 pi into m by bq, right? We have learned that time period of revolution equal to 2 pi into m by bq. Now it completes a half revolution. For a half revolution, in the place of 2 pi, we are taken now pi. So pi into m by bq. Now see what he is saying. The time spent in region 2 is the same for any velocity v as long as the particle returns to region 1. So returns to region 1 only when it follows semicircular path. In that case, time taken, pi is a constant, mass is a constant, b constant, q constant, all are constants. That's why time spent is the same. That's why option D is correct, right? Let us see. So final options are, it is A, C and D. Okay, right. Let us see next one. See the question given. Again, same as previous questions only. Mass m charge given positive, velocity constant, given 4 I cap along positive x-axis, enters a region of uniform static magnetic field. Given uniform, condition static means magnetic field is not changing. Okay. The region of magnetic field extends from x equal to 0 to x equal to L for all values of y. After passing through this region, the particle emerges on the other side after 10 milliseconds with a velocity. And again, you have to cross check here. Because of magnetic field, speed does not change. Speed is a 4. See here also, speed is a 4. See modulus value. It is again 4, right? Modulus value 4. After a time, 10 milliseconds. We have to verify options, direction of field and magnitude of field. Okay. In fact, we can solve directly, same as previous problems. At first, focus the given data. Magnetic field extends from, x equal to 0 to x equal to L. Suppose this is now x-axis. This is x-axis. Right. Velocity of the particle. Given charge is positive. It enters at origin. Right. Now he's asking direction of field, strength of field. It comes out of the field after a time 10 milliseconds. Okay. Initially, velocity given u1 bar 4 I cap. So you have to focus mainly the velocity vector given. Okay. It has positive x-axis. See, root 3 I cap, x component positive, plus j cap, y component also positive. That means particle is deflecting, or you can say it is confined to xy plane. It is now in which quadrant? It is in first quadrant. Okay. If you take now, this is origin. Okay, exterior at origin only. So the path must be like this. So I hope you're getting this point. Path must be like this. In such a case, if you take velocity, it is always along tangent. If I'm taking tangent here, you can see components along positive x, along positive, right? So condition 1, force must be along positive y-axis. See here what I am doing? F bar equal to given charge positive, okay, no? Q positive. V bar direction is I cap cross B bar direction that we have to decide, and direction of force must be J cap. So I cap cross something should be J cap. Okay. Then this must be, see carefully, I cap, J cap, K cap. If you are taking K cap cross I cap, that is J cap, but we have I cap cross. So this must be minus K cap, right? That means which option matches. It is option A, right? Negative the direction. Next, coming to magnitude of B. Then see what I am doing here. Just now I have discussed time period of revolution 2 pi into m by bq. Now time given how much? 10 milliseconds. 10 milliseconds means 10 power minus 2 seconds. That is equal to, in the place of 2 pi, see what we have to write. What we have tried. See carefully once. Diagram. Suppose this is our location, okay, while coming outside. If you draw here normal, this will meet at center, right? And you can see angle made by this velocity vector with x-axis. And that will be, see how much? If this is now theta, this also theta. Angle made by velocity vector with x-axis. It is a Vy upon Vx, right? It is simply vectors, nothing else. So it is now 1 by root 3. That means theta equal to 30, right? 30 means then what I have to do? In the place of 2 pi, I have to write 2 pi by 6. Because it is now how much? 30, right? Wait, let me cross check one. 30 means how much? It is a pi It is now 2 pi means 360. 360 by 6 means 60, right? So it is not a 6. Let me correct this one. To complete one revolution, we are taking 2 pi. Okay. To complete now this to rotate by an angle 30, we should write here it is 30 only. That is pi by 6. Okay. Into m by b. Now we have to find b value. So b value how much? Take b to left side and this is here pi m by 6 cube. This is now by 10 power minus 2. Becomes 10 power 2 means 100. Or I can cancel this one to here. It is now 50 upon 3 into pi m by q. This is our answer. Okay. So main thing here we have to focus from this velocity vector we can get by what angle velocity vector is now. Our velocity vector makes angle with the initial direction of motion. Then time period is 2 pi into m by b cube. It is now only 30. That's why I am taking 30. And time given 10 milliseconds. That is 10 power minus 2 seconds. And remain just calculation. Okay. That means options are is option A and option C. Right? Okay.